Hi class, to continue completing the square, we're going to look at the situation when the a value is not equal to 1. So in the previous examples that we've done, all the a values in front of the x squared have been 1. But as we know from seeing different standard form equations, that is not always the case. So if we look back to what we're trying to achieve, which is to create a vertex form where we have the bracket of x minus h squared, you'll notice that the value in front of this x value is singular. It's 1. If we kept the a value attached to the x squared in this standard form, and we tried to do a perfect square factoring, this value in front of the x will no longer be 1. So if we wanted to create this vertex form in the format that we like, where it's a bracket x minus h squared, see how this a value, it's separated from the x minus h. So therefore we must factor it out away from the bracketed x minus h squared. And so that's going to be our very first step when we deal with standard form equations where a is not equal to 1. We have to first factor out the a value. And so we'll take it 2 in this case, and we'll take out from 2x squared divided by 2 is just an x squared. 12x divided by 2 is just a positive 6x. And I'm only going to take it out from the first two terms. As we saw in the previous cases, this c value was not impacted and it became part of the k value. And so it does not need to be, the a value does not need to be factored out of it. It does not interfere with the k. So we're just going to leave that plus 18 outside of the bracket. And then we're just going to continue like we did before. We're going to look at the b value here, and we're going to divide it by 2 and then square it. So we'll have 6 divided by 2, which would be 3. Square that, which would be 9. So I know that I'm going to add in and subtract 9 into the beside the 6x. And so it becomes y equals 2 bracket x squared plus 6x. Now I'm going to add 9 and subtract 9 inside that bracket with everything else, and I'm going to have that plus 18 trailing behind. And from there, I'm going to only take the x squared plus 6x plus 9 and turn that into the perfect square that we want, which is x plus 3 squared. I have my y equals 2 still in front, and then I still have my 18 trailing behind. But what we haven't dealt with right now is we haven't touched the minus 9. And so what happens with this minus 9 is that it doesn't stay. It can't be part of what's in the bracket anymore, remember? Because only these three terms turn into this perfect square. So I actually have to remove that minus 9, but not remove it from the equation because it needs to be part of it because we can't change the equation. So what it has to happen is I have to take this minus 9 outside of the bracket so it doesn't become part of the bracket anymore. But if I were to remove it, it was sitting inside this bracket, which meant that everything inside this bracket had to be multiplied by 2 first, according to BEDMAS. So if I'm going to remove the minus 9 from the bracket, I must multiply it by that a value first in order to take it out. So then, therefore, the minus 9 times 2 gives me a negative 18. And so, yes, in this case, you'll see now that my equation turns into y equals 2 bracket x plus 3 squared. And in this case, and only because of this case, of the way the numbers worked out, it's a minus 18 plus 18, which ends up being 0. So it kind of disappears. But that is not always the case, okay? And then you might end up with a c value in the end. But what the key factor here is knowing that when we have a trinomial, when the a value is not 1, you must factor the a value out of the ax squared and the bx only. You leave that c because it doesn't get impacted. And then you have to remember to multiply the a value with the minus the b over 2 squared, that missing squares amount, and then when taking it out of the bracket, okay? So those are two key things to remember for this case. All right. Okay, so we're going to try one more just to make sure that we understand this. So now we have the example of y equals 3x squared minus 6x plus 20. So as we stated, we need to remove that a value first. So we're going to factor it out. So we have 3 factored out. What left over would be x squared. Negative 6x divided by 3 would be negative 2x. And then we're just going to leave that plus 20 at the end. And then we're going to look at that b value, and we're going to find out the missing squares. So we go b over 2 squared. So that means negative 2 over 2 squared, which means it's negative 1 squared, which is just positive 1. So in the equation, I have y equals 3 bracket x squared minus 2x. I'm going to add a 1. I'm going to subtract a 1. And then I have my plus 20. Don't forget that at the end. And then looking at what's inside the bracket, in the first 3 terms here, the x squared minus 2x plus 1 is going to be a perfect square factoring, which becomes an x minus 1 squared. Remember that the sign of the b value here will be the sign inside my perfect square factoring. So I have y equals 3, and then to kick out the negative 1 out of the bracket, I must multiply it by the a value. So that means I have minus 3 out here plus 20. And so my final equation will become y equals 3 bracket x minus 1 squared minus 3 plus 20 is positive 17. And so my vertex form of my quadratic in this case is y equals 3 bracket x minus 1 squared plus 17. So if I plug this in and I plug the original equation, I would get the same graph. All right, remember, now let's just take a minute to talk about why are we doing this? Why are we transforming standard form to vertex form? So before you do the exit ticket here, I'm just going to talk a little bit about that using this example here, which is going to do it one more time to make sure we understand it. We're going to take this standard form quadratic and convert it to vertex form. So we'll do y equals, in this case the a value is 1, so I don't have to do any factoring. I just take my b value and divide it by 2 and square it. So that would mean 6 divided by 2 squared, which is 3 squared, which is 9. So I'm going to rewrite the equation of x squared plus 6x. I'm going to add 9 and subtract 9 before I have my positive 8 at the end. And the first 3 terms here of x squared plus 6x plus 9 will become a perfect square factoring of x plus 3 squared. And then my minus 9 plus 8 at the end will just simply become minus 1. And so this is my vertex form of the original quadratic equation. So looking at this vertex form, it gives me so much information about the quadratic. It tells me that my vertex is sitting at negative 3 and a negative 1. Remembering that this is x minus h, and this always is the opposite of what you think. So naturally, if you see x plus 3, you think it's going to move to the right, but it's really going to move to the left, negative 3. And that x value is also my axis of symmetry. So the axis of symmetry equation would be x equals negative 3. And the direction of opening is always that a value. In this case, it's 1. It's a positive, so it means it's going to open up. And to find the y-intercept, I actually have to go back to the standard form, and that is always going to be the c value of a standard form. So then I know already that my x-intercept is at 0, my y-intercept, excuse me, is 0, 8. And that gives me so much information for me to graph my quadratic. All right, so if I look at all this, I know that my vertex is sitting at negative 3 and negative 1, so I have a dot there. I know that my y-intercept will eventually happen at positive 8, which makes sense. I'll have my axis of symmetry along that negative 3 x value. X equals negative 3. And because there was the a value is 1, I know that the stretch factor, there is no stretch factor, is simply just like the parent function. So therefore I'm moving over 1 from the vertex, up 1. So there's my next dot, symmetrically is over here. From the vertex I go over 2, I go up 4. And then had I gone 3 over, I would have to go 9 up, which is exactly where that 8 is. I'm just going to mirror it on the other side of my axis of symmetry. And now graphing it with my arrows, because quadratics continue forever. And there is my quadratic. So if I plug this in, whether you're looking at the vertex form or the standard form, this is my quadratic equation. All right, and so I would like you to now try out the exit ticket. There's a couple questions here. 5 are mandatory, 6 is the extra challenge. To see if you understand it, and good luck.